Hi, everybody. Welcome to day one of e-learning. Hopefully, all is well in Glendale Heights. I am broadcasting live from Schaumburg. So, not as much fun to be in my office talking to you via computer screen. I'd much rather be with you in person in our class. But this is what we'll have to do for now. On a side note, I hope that you guys are all well. I hope you guys are spending time with family, making sure you're washing your hands. If you guys have any questions or concerns, please feel like you can reach out to me. I will literally be sitting by my computer for the next 1,000,000 hours. All right. In terms of your math class, it's going to look a little bit different than my regular math classes. You guys are on a pretty strict schedule to make sure that you complete all of your algebra lessons before you get to high school because we don't want you to be behind all the other kids. So we're going to start off with like a little bit of a review, and then we're going to push forward as much as we can. Now, I need you guys to tell me, like, if we're going too fast or it's too much information to distribute via video, you let me know and we can slow down. Like, for example, if we do one topic in one day and then we do another topic the next day and you're like, oh, this is too much. Like, can we slow down? Can we have more of a practice day? Just let me know. And I'm very open to that. It's kind of hard to tell via video screen how you guys are doing versus in person. So you be honest, you let me know. You can message me, post it on Schoology, etc. All right, so today, day one of e-learning, we are reviewing systems of equations. Your jobs for today, or actually like throughout the lesson, here's what we're going to do. We're going to cover some key points about systems, talk about the three graphing methods, what your answers can look like, and then we'll talk about your assignments for today and for later this week. I saw some of you guys already did the problem solving document. Oh my gosh, that is awesome. I was so happy to see that in my meeting, but it's not due until Thursday. All right, so we are looking to solve a system of equations using the graphing, substitution, or elimination method. Remember that many of us had our favorites, but we need to make sure that we can use all three. All right, when we're talking about a system of equations, remember that is two equations that are working together to solve for two variables. Oftentimes we see them as x and y, but it could be a and b, it could be Q and R, I don't know. But it's two equations that work together to solve for two variables. Remember that we write our solutions as a coordinate pair with your parentheses with the comma in the middle. Unless you're talking real world problems, we write those solutions in the context of the problem with units, labels, etc. Moving on, we have three methods to solve a system. We've got graphing, substitution, and elimination. Personally, and I think we all kind of agreed as a class, graphing's the easiest when it's possible for us with our equations. Substitution, elimination, very quick and easy, very procedural. So just remember, I'm going to show you a few quick tricks how to figure out which method is the best and how to really do that. All right, method number one is graphing. You want to use this method when you've got equations that are in slope-intercept form, which is y equals mx plus b, or if you have equations that you could easily manipulate into slope-intercept form. So if you're looking at your blue example here, both of these are already in slope-intercept form. So you could quickly start at your y-intercept, graph your slope, and wherever your graphs cross the two lines, that's your solution. With your green box here, you've got your bottom equation that's in slope-intercept form. Your top one is in standard. All you'd have to do is just move over your 2x by subtracting, and then you're good to go. If you don't remember how to convert from standard to slope-intercept form, you should pause this slide and kind of take a look at the information, the examples that you see. Essentially, what you're doing is you're solving the equation for y. You want to isolate y on the left side. So if you're looking at this one on the left, you start with this in standard form. Standard form is ax plus by equals c. To start to isolate y, we need to move over 6x, and we use inverse operations. So because 6x is positive, we would subtract it to both sides. We're then left with 2y equals negative 6x plus 24. To get rid of that coefficient of 2, you need to divide every single piece by 2, and then you're left with y equals negative 3x plus 12. Here's just another quick example. I really like how they say to change from standard to slope-intercept, you're just solving the equation for y. So again, if you need to pause, maybe try this out on your own, please do so. But it's a powerful tool for you to have, especially before we hit Unit 5 together in Algebra. We will do that in person because that's a little bit too much for computer screen. So method number 2 is substitution. This is the method that you want to utilize when you have one variable that's isolated usually you want to stick with when you have one variable that's isolated, that's your best method. So for example, you see that you've got y is equal to 2x minus 3. Wherever you see a y, sorry about that, wherever you see your y here, you're going to plug in 2x minus 3. And then you'd use distributive property to simplify, and you go on from there. In your second equation, you've got x is equal to 2y. And so wherever you see your x right here, you're going to plug in 2y. Then you'd have negative 3 times 2y, and you'd keep going. So essentially, you look for your variable that's isolated, plug it in where you see it, simplify, solve for that variable, substitute in again. Next method, probably my favorite, the most procedural, most black and white, is elimination. When you are solving using elimination, your key to look for it is that you've got x's stacked on top of y's. When you see those two lined up with one another, that's your clue that you're going to be eliminating. Remember, you cannot eliminate variables unless the coefficients match. So to show you, in your blue example here, you could eliminate your y's because you've got plus 2y and plus 2y. Remember, if it's the same sign, subtract going down. But maybe like if your top one was minus 2y, because they would be opposite, then you'd add going down. If, like in the green example, if you don't have variables that match, you can multiply one or both of the equations to get coefficients that do match. So if you wanted to make the x's be the same coefficient, you could multiply your top one by 3, your bottom by 2. That would give you a coefficient of 6 and negative 6. Your variable for y, if you've got 4 and 7, we know that they both go into 28. So you could multiply your top one by 7, bottom by 4, and then you have 28y, 28y. So your keys here, you see x's and y's stacked up, eliminate them. You can't do that unless you have matching coefficients. And if you've got opposite signs, you're going to add going down, same sign, subtract. Don't forget the elimination or the alliteration. That's going to help you remember. When we think about systems of equations overall, there are a few options for the number of solutions that you have. The first one is no solutions. If you ever see two equations that have slopes that are equal or the same, those would produce parallel lines. Those will never touch. Therefore, there's no solutions. So if you had like y equals 2x plus 5 and y equals 2x minus 11, you see 2x, 2x, those are going to be parallel lines, no solutions. You don't have to do anything else. You can also have infinitely many solutions. That can only happen is if your two equations produce the same exact line. You'll often find that if you need to convert one into standard form or standard to slope-intercept. So if you see two lines that are the same, they're coinciding, then you don't need to do anything else. There's infinitely many solutions. Last option is that there are one solution. Now, the most common is if you just have two intersecting lines, that intersection point is your solution. However, something more specific and more, a little bit more advanced, something that you guys can handle. If you see a system of equations that have slopes that are opposite reciprocals, they are going to be perpendicular lines, meaning the point in which they cross produces a 90-degree angle. When we think opposite reciprocal, we think like 2 and negative 1/2, or negative 3 and 1/3, or 4 and negative 1/4. So you take the reciprocal, you make it the opposite. You see those two, you know that there will be one solution, and the two lines will be perpendicular, meaning they create a right angle. All right, just to kind of close here, it is important not only that you look through your notes for all three methods, but that you choose the solving method that's going to be the easiest for you to get to your solution. Work smarter, not harder. We're honors kids. We're good at doing that. All answers should be written as ordered pairs. Pay attention to how Pearson asks you to write your answer. So many of the times you guys will submit it in a way like you forget parentheses or you forget your comma. I can see your values are correct. It just marks it wrong because it's Pearson. If you need additional review problems or videos, go to Schoology, go to the 8th grade CCSS folder, Common Core State Standard, and go into the Unit 5 folder. There you'll see that there are a few videos that my kids made last year that you can watch for extra practice problems. All right, best part, your Tuesday assignment for e-learning day 1. There's a lesson quiz online Pearson. It's called Systems of Equations 31720. If you could do that and submit by 9 o'clock tonight, that would be lovely. And then number 2, your problem solving number 3 is due Thursday at 11:59. 11:59, it is due. I need you to submit by that time so that when I post the video on Friday, you're not just sitting and watching the video and watching me do each problem, and then you'll submit after that. So do it. It's okay if you get the wrong answer. It's not okay not to try. Okay, I think that's it. Miss you guys so much. See you tomorrow via video. If you have questions about anything, please don't hesitate to reach out. Bye.